In this video, I'm going to talk about cards and the expected value. So, the definition of the expected value of a random variable x is given by the probability distribution of the random variable x. So you have x, all your possible values of x, and then the corresponding probabilities. So the expected value of x is denoted by E of x, and it's x times its corresponding probability. So basically what you do is you just multiply these and then add them all up. So in this problem, a 5-card hand is dealt from a standard 52 card deck. If the hand contains at least one king, you win $10. Otherwise, you lose $1. What is the expected value of the game? So we are going to use the complement rule. P of E is equal to 1 minus P with E with the little apostrophe at the end. And we're going to use that to determine the probability of being dealt at least one king. So this is the complement rule. The complement rule is, if you remember how it would go, it's equal to 1. Okay? Except we're just going to switch it. We use some basic algebraic steps to get P of E by itself. Alright, so what we're going to do is find the probability that your first card is not a king. So basically, let me go back. The complement of being dealt at least one king is being dealt no kings. Okay, no kings. So we want to look at all 5 of our cards and figure out the probability of you not getting a king. Okay, so let's find the probability that your first card is not a king. So you know you have 52 cards in the deck. We know 4 of those cards are kings. Okay, so that means the other 48 are not kings. So that's how you got 48 over 52. So now you take that card, you put it aside. Now you have 51 cards in the deck. You still have 4 kings because you didn't pull out the king the first time. You still have 4 kings. So 47 of the remaining cards are not kings. Take that card, put it to the side. So now you have 50 cards left. You still have 4 kings because you did not pull out a king the last 2 times. So now you have 46 cards that are not kings. Okay, take that card, put it aside. Now you have 49 kings. Sorry, 49 cards. Still got 4 kings. So 45 are not kings. Okay. Lastly, the 5th card. Now you have 48 cards in the deck. You still have 4 kings. So 44 of those are not kings. So we got each one of these fractions, and what we're going to do is we are going to multiply them all together. And that will give us the probability of not being dealt a king. And when you multiply all these together, you get 0.659. Now we're going to use the complement rule to find the probability of being dealt at least one king. So basically you're going to take 1 minus the probability of getting no king. Okay, so we already said the probability of you not getting a king is 0.659. That's what we got here. When we subtract it from 1, we get 0.341. So the probability of you getting at least one king is 0.341. So now let's go ahead and find the expected value. Okay, so in order for you to win $10, you have to get at least one king. The probability of you getting at least one king is 0.341, and we know we win $10. The probability that you do not get a king is 0.659. And if you don't get a king, then that means you lose $1. Okay? So we're going to take these numbers, 0.341, and we're going to multiply it by 10. We get 3.41. And then 0.659 times -1 is just a negative 0.659. So I'm going to subtract that from 3.41. I get 2.75. So therefore, the expected value of the game is 2.75.